Hello Evan, I hope you're well. Welcome to today's maths video lesson. I hear you're getting Wi-Fi sorted out in the next week, so there's a whole lot of videos to catch up on. It's going to be like a math series, I guess. And this video is just going to follow on from the work plan sent out for this week. So I just want to recap exponential functions and also talk a little bit about reflections. So I did a video on the exponential function earlier in the month on the 12th of May, and it's been a long time since then. So today will just serve as a little bit of a recap, and then we're going to go into some questions, how to find the equations of the graphs and some of the more complicated examples. So I'm going to start off with the simplest case of the exponential function, y equals 2 to the power of x, and I'm just going to plot it quickly. So I'm going to pick x values, -2, -1, 0, 1, 2, and let's work out the corresponding y values. 2 to the -2 equals 1 over 2 squared. Remember, with the negative exponential, our rule is to flip it and then change the sign from negative to positive. So the -2 becomes a +2, and this works out to a quarter. Same idea for when we substitute this x value, we would have 2 to the power of x, so it's going to be 2 to the power of -1, and that equals to 1 over 2 to the 1, which equals half. For the next value, when we substitute 0 in, we get 2 to the power of 0, and any number to the power of 0 is always 1. Next, 2 to the power of 1 is 2, and 2 to the power of 2 is 4. So let's plot this quickly. Specify our axes. And our x values, -2, -1, 0, 1, 2. Our y values are 1, 2, 3, 4. So now let's plot these values. We have -2 and a quarter, so half, quarter, -1, half, 0, 1, 1, 2, and 2, 4. So our graph looks something like this. Now, if you recall, this graph increases at quite a rapid rate, and on the other side of the y-axis, if you look at what's happening here, it's decreasing, but it never quite reaches 0. So we say that it has a horizontal asymptote for the line y equals 0, or in other words, the x-axis. So let me just plug in some numbers so you can understand where this asymptote is coming from. Remember, definition of the asymptote is that it tends very close to a value, but never quite reaches it. So I'm going to make the x values larger and larger negatives. So we're going like this along the x-axis. So let's pick some x values. Let's do -2, -10, and -100. Okay, so x is getting more and more negative. Let's look at our y values. We have 2 to the -2, which equals to 1 over 4. If we substitute -10, we get 1 over 2 to the power of 10. And if we substitute 100, it's 1 over 2 to the power of 100. So let's look at what's happening to the corresponding y values. All of these y values are positive fractions. Quarter, the 1 over 2 tenths, and the last one. And what's happening is that our denominator is getting bigger and bigger. Okay, so we have fractions which are getting correspondingly smaller and smaller. Okay, so if we take 1 and divide it by a very big number, we get a number very close to 0. And as our denominator is getting bigger and bigger, we're moving closer and closer towards 0. Now notice, no matter how big we make x, or sorry, rather how small we make x, how negative we make it, it will never quite reach 0. So even if we put a huge negative value, like x equals negative 1000, we're still going to get this very small positive fraction, y equals 1 over 2 to the power of 1000. So that explains what's happening here, and visually you can see how this asymptote is showing up. Okay, next I want to talk a little bit about some reflections. So we're going to be considering reflections about the axes, reflections about the x-axis and the y-axis. So we're going to start off once again with our base case, y equals 2 to the power of x, and the reflection about the x-axis is if we take this graph and flip it. So it's almost as if there's a mirror here and it reflects the exact same thing. So that graph would show up as y equals, or sorry, negative y equals 2 to the power of x. Okay, so remember from the video on the 11th, when we make y negative and keep x the same, we're keeping these x values all the same, and we're taking the y values and flipping them. So our reflected graph would look like this. Now let's look at a reflection about the x-axis. So that would be where we take this graph and flip it this way. So all the x values are flipped while the y values stay the same. So how does that show up in the equation? We keep y the same and we make x negative. So let's see how this would look. If we take this x value and make it negative, this x value make it negative, this x value is already negative. So if we put a negative to a negative, it goes this way, it becomes positive. And the same thing for this value, it gets flipped on that side. And our reflected graph looks something like this. So these kinds of reflections not only hold for the exponential function, but for all the other functions that we've looked at. So now I want to look at the reflections of the hyperbola and parabola. Okay, the first parabola I want to look at is y equals x squared plus 1. Let's draw a rough sketch. So first things first, I'm going to take the 1 over to the other side. And now you remember that if we have a constant next to one of the variables, that corresponds to an axis shift. And when the constant is applied to the y, it means it's an x-axis shift. So the x-axis is flat, it can either move up or down, and this minus 1 tells us that it moves 1 down. So starting off with our standard parabola, which has the equation y equals to x squared. Now when we have a plus 1, as in this equation, we can see that it corresponds to the x-axis shifting 1 down. So this is our old x-axis for the standard graph y equals x squared. And now we're going to move the x-axis 1 down. So that's our new x-axis, and I'm just going to rub out the old one. And our shifted graph looks like this. Okay? So now let's look at some reflections. If we reflect this graph about the y-axis, it wouldn't make any difference because this graph is symmetrical about the line about the y-axis, the line x equals 0. So this branch would just reflect perfectly here, this branch would reflect there, and we'd get the exact same shape. So in this case, I'm only going to look at reflection about the x-axis. So whenever we reflect about the x-axis, we keep our x values the same and we flip our y values. Okay, so let me redraw it. So when we keep our y values, we keep our x values the same, x squared plus 1 stays the same, and we make y negative. So now if we just want the equation in terms of y, we bring the negative over to the other side to get y equals negative x squared minus 1. So how is this graph going to look? So this was our equation, this was our graph for the equation y equals x squared plus 1. And the reflection about the x-axis, we're going to take all of these points and flip them. This one there, this one there, and we get a graph that looks something like this. Okay, so this is the equation, y equals x squared plus 1. This is the reflection, y equals minus x squared minus 1. Okay, now I want to look at a slightly different parabola so I can illustrate reflections about the y-axis. So this one didn't work because the reflection just gives the same equation. Let's pick y equals to x minus 1 squared. Okay, so this is the turning point form of the parabola, and our turning point is the value that makes this bracket 0, and here we don't have a bracket, so y is just going to be 0, giving us a turning point of 1 for the x value and 0 for the y value. So just remember the value of x that makes this bracket 0 is 1, because 1 minus 1 is 0. Okay, so our turning point sits there. Our y-intercept is when we make x 0. So it'll be 0 minus 1 is minus 1, squared is 1. So it will be there for our y-intercept, and our graph would look something like this. Okay, now let's look at a reflection about the y-axis. So I'm going to take each of these points and flip them. If the points are negative, when I flip them, they're going to become positive. So when I flip about the y-axis, I keep y the same, and I make x negative. So this would be our equation. And if this was our old graph, y equals x minus 1 squared, our new graph would be if we took this point and reflected it, this point stays the same, this point would be reflected, this point would be reflected, this point over here gets reflected all the way there. So we can see we get a graph like this, and the equation is y equals minus x minus 1 squared. So we've just taken this and flipped it. Okay, lastly, let's look at some reflections for the hyperbola. So once again, we're going to start off with our standard equation. For the hyperbola, this is y equals 1 over x, and the graph looks something like this. So firstly, we're going to look at a reflection about the y-axis. So this is going to be our reflection axis, and we're going to flip this branch this side and this branch this side. So when we're flipping about the y-axis, we keep y the same and we make x negative. So that will be our new equation, y equals 1 over negative x. How will this look? I'm going to sketch our old graph like this, and if we flip this point here, this point, then this branch would reflect like that, and the lower branch would reflect over there. And this is what our reflected graph would look like. Now let's look for a flip about the x-axis. So we would flip the upper branch this way and the lower branch up. So if we're reflecting about the x-axis, we make y negative and we keep x the same. So this equation in terms of y, we bring the negative over to the other side. So y equals negative 1 over x. And at this point we could bring the negative to either the numerator or the denominator. I'm just going to bring it to the denominator and we get this equation. So it's exactly the same as the equation for reflection about the y-axis. Okay, our equation is y equals 1 over negative x. So we expect to get exactly the same graph. Let's check. Y equals negative 1 over x. So our standard graph looks like this. And we reflect about the x-axis. This point over here, so we would get our reflected branch there, and this branch reflects upwards if we're reflecting about the x-axis. Because these are negative values, when we assign a negative to them and flip them, they become positive. So this one flips here, this one here, and we get a branch like this. Then we rub out the old equation, and we can see that yes, indeed, we have the same graph as for the reflection about the x-axis. So now we're going to do some examples, and our examples incorporate a mix of everything we've looked at so far. So we've looked at axis shifts, horizontal shifts and vertical shifts. We've looked at reflections, and we're going to put them all together.